Chapter 6.3, Quick Review, page 529. This section is related to the parametric equation. So this is kind of get ready for dealing with parametric equations. And exercise 1 to find the component form of the vectors OA, vector OB, and vector AB, where O is the origin. Well, O is the origin, so vector O, we're going to say is this point here, 0, 0, and we're just going to go head minus tail to find the vector. So for A, we're going to say OA is going to equal, we're going to have, we have head minus tail, where A is the head, so we're going to have -3, -2. O is 0, 0. I'm going to rewrite this, make this a little clearer, I hope. So vector A is -3, -2. Vector O is 0, 0. And we subtract vector OA is equal to, put this in form with angular brackets, -3, -2. All right, let's look at problem B. B, we're going to have OB. Well, in this case, the head is going to be B. The tail is the O. So we'll put B, head minus tail, 4, 6. And the tail is O, which is 0, 0. So we have vector OB is in component form. 4 minus 0 is 4. 6 minus 0 is 6. We have 4, 6. And then C. Part C, we're going to have AB. Well, in this case, we're going to have our head is going to be B. So we have B, which is 4, 6. And A, which is -3, -2. And here we have AB is vector AB is equal to 4 minus -3 is 7, and 6 minus -2 is 8. So these are our answers right here. A, B, and C. Next, odd number problems. We're not odd number problems. 3, write an equation in point-slope form. Well, what is point-slope form? It's the equation y minus y sub 1 equals m times quantity x minus x sub 1. So what we needed point, and a slope. So let's go ahead and find the slope. To do that, I'm going to create a little table over here to the left. We'll have -3, -2, and 4, 6. And if we subtract, 6 minus -2 is 8. 4 minus -3 is 7. So slope is m equals rise over run, change in y divided by change in x, so 8/7. I'll put 8/7, that's our slope. In point, we can use any of these points. Okay, so we'll just use this formula here. And so we'll say y minus y sub 1, so we're going to say minus -2, so that'll be y plus 2 equals 8/7, which is m, times x minus -3, which is going to be x plus 3. So that is it in point slope form. Okay. Problem number 5. Exercise 5.6, find and graph the two functions defined implicitly by each given relation. So we have y squared equals 8x. To solve for y, we take a square root of both sides of this equation, so we get y equals plus or minus the square root of 8 times the square root of x. So those are two functions defined. And so we can just leave this like this. We could rewrite the square root of 8 if we wanted to as 2 square root of 2. That's not too important. To graph. Okay, we go to calculator and get a graph page. And F1, we're going to say y equals square root of 8, and then times square root of x. Oops, they got a lot of different x's in there. There's just one x. Okay, and that is our graph right here. Stretches quite a bit up. And then the negative version, negative square root of 8 times square root of x. There we have it. Two functions, the one in blue, the one in red. We can sketch the graph. There it is. There they are. Two implicitly defined functions. Okay. So if we had to draw that sketch, this sketch is going to look like one function like this. The other function, the negative reflection of the same. So there. Okay, those are more or less looking like reflections. There they are. Next, problem 7. In exercises 7 and 8, write an equation for the circle with given center and radius. Well, the standard function for a circle is quantity x minus h squared plus quantity y minus k squared equals r squared. And here we are given a radius. Here we're given h and an x, right? So, since we have h is 0, we have x squared. And since y is 0, we have y squared equals r squared. Since r is 2, r squared is 4. This is our equation. In problem 8, when you work problem 8, it's the one that's more complicated than problem 7. I think it's going to be quantity x plus 2 squared times plus quantity x y minus 5 squared equals 9. I just gave you a freebie verbally for 8. Okay, this one here, in exercises 9 and 10, a wheel with radius r spins at a given rate. Find the angular velocity in radians per second. We're given a revolutions per minute, and we're given a radius, essentially we are going to get 2 pi radians per revolution. And that's just our knowledge, like the unit circle. We go all the way around the unit circle. We get to 2 pi. It's equivalent to 360 degrees. So 2 pi radians, our circle is a little over 6.28 radians. And we are rotating at 600 revolutions per minute. And we cancel what we have divided by each other. Revolutions over revolutions cancel, so we have radians per minute. So how do we change our minutes to seconds, since we want the angular velocity in seconds? Well, 1 minute, which we put in the numerator to cancel, is equal to 60 seconds. And we work this out. It's kind of the arithmetic. We can cancel a 0 here. So we have 60 divided by 6 is 10. So we have 2 pi times 10. And we have left radians per minute, right? 2 times pi times 10, which equals 20 pi radians per second. Oops, I forgot to cancel out minutes, didn't I? There we are. There's minutes. Minutes. We have radians per second. There we go. Stick around enough, I'll eventually get it right a lot of times. So we have radians per second. Anyway, those are all the odd number problems worked out from this set in preparation for going to parametric equations. And I thank you for viewing. Bye.